simulation portion of this module, we're going to have 3 different stations to demonstrate the different principles that were learned during the lecture. The first station is going to demonstrate the different tissue effects that you can achieve by using the different waveforms and different techniques. So for the first station we have a chicken breast, and the first thing we'll demonstrate is vaporization, which is achieved using the cut button, which is continuous low frequency, and we will perform the non-contact technique in order to achieve vaporization. So press the button prior to contact, vaporization. Secondly, we can use the coag button in the non-contact technique to achieve fulguration. So we'll demonstrate that second. You can see it travels much slower through the tissue. And then the last tissue effect that we can achieve using either the cut or the coag button is desiccation. However, this is performed using contact technique. So apply it to the tissue, press the button, desiccation, and then again with the coag button. So if we take a knife and cut through the chicken breast, you can see that for the area that we used vaporization, there's minimal thermal spread, versus the area where we used fulguration, there's much more thermal spread, which you can appreciate on the chicken breast there. The second station is a leap station, and again this will be used to demonstrate different tissue effects. Well, this is not ideal because I can't get the demo mode to work. So normally this would be, this hot dog would be inside a toilet paper roll, which would simulate the vaginal walls, and the hot dog simulating the cervix. But we can still appreciate the effects and the principles of electrosurgery here. So when performing a leap, you really want minimal thermal spread so that your pathologist can give you an appropriate read on your pathology. And so the ideal way to get your specimen is to use the vaporization technique. So again, this is achieved using the cut waveform, which is low frequency continuous, and we would use that in the non-contact technique. So we'll press the button, make our way through. And as you can see on the specimen, there's minimal charring. So this would be a good specimen for the pathologist to read for you, because you don't have much thermal spread. Secondly, typically in a leap procedure, you would have some bleeding from the leap bed. And so to achieve hemostasis there, you could either use fulguration or you could use desiccation. And again, desiccation can be achieved using either the cut or the coag button in the contact technique, or fulguration using the coag button in the non-contact. So we'll use desiccation because let's say it's bleeding quite a bit. So we'll contact the tissue and use the coag button so we can get a deeper coagulation of the tissue. And that would help you achieve hemostasis. In the third station for this simulation, we're going to demonstrate capacitive coupling. So what I have here is a light bulb, and it's wrapped with the bovie pencil, the wire from the bovie pencil. I'm going to turn the lights down so that you can appreciate this. And again, this is demonstrating capacitive coupling. So just pressing the button, you can see that energy will actually transfer, despite the insulated cord, transfer into the light bulb and actually eliminate. That was using the cut, and again, coag. So that's the end of the simulation for this module.